This is Dr. P. Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about question bank. So, in question bank, now we'll discuss about Module 5, Test of Hypothesis 2. So, that is nothing but test of hypothesis for small samples. Question bank, discussion of test of hypothesis 2. So that is nothing but test of hypothesis for small samples. So in question bank, in our question bank, we have three parts. So first one is part A. So that is about small short answer questions. Next one is part B. So that is long answer questions. And part C is based on problem solving and critical thinking questions. So part A, short answer questions. First, we will discuss about part A, short answers questions. So, first we will discuss about how many topics are there in our module 4. So, in module 5. So, module 5, so this is based on test of hypothesis 2. So, that is nothing but test of hypothesis for small samples. So, in this we have only three topics are there. First one is t-test or t-distribution. Second one is f-test or f-distribution. And third one is chi-square test or chi-square distribution. In t-test we have t-test for single mean or t-distribution for single mean and t-test for difference of means. And f-test and chi-square distribution, we have three methods are there. So, first one is based on only the average of observed frequencies, and second one is based on the expected frequencies based on binomial and Poisson distribution. That is nothing but fitting. Last one is independent of attributes. So, first one is average of observed frequencies, second one is based on goodness of it, and third one is based on independent of attributes. So, this is our these are all topics in 5th module. So, coming to the part A. So, what is our first question? If x bar equal to 47.5 minus mu equal to 42.1 and s equal to 8.4 and n equal to 24, then find t. So, how to find t value? So, we have, so this is totally based on t distribution for single wheel. This comes under t distribution for single wheel. So, what is the formula for t distribution for single wheel? So, that is x bar minus mu by s by root n. The formula is x bar minus mu by s by root n, or we can use x bar minus mu by s by root n minus 1 also. So, but here we have x bar is 47.5, mu is 42.1 divided by s is 8.4 divided by and the root of n is 24. So, by using this one, we can find t value. So, next question. So, coming to the next question, so list the difference between t-test and f-test. So, in t-test, we have single mean and difference of means is there, and in f-test, we have that is based on variances. So, t-test is based on means and f-test is based on variances. Okay, so in t-test we have single mean and difference of means, but in variances we have only one method is there. Okay, so t-distribution formulas are x1 bar. This is t-test for single mean, and in this we have t-test for single mean, that is x bar minus mu by s by root n, and also we have t-test for difference of means, that is x1 bar minus x2 bar divided by s into and the root of 1 by n1 plus 1 by n2. Okay, so here that will be f equal to s1 square by s2 square, where s1 square greater than s2 square, or we can use f equal to s2 square by s1 square, where s2 square greater than s1 square. Here t distribution for difference of means is we have to take t alpha at nu equal to n1 plus n2 minus 1 degrees of freedom. And here we have to take t alpha at nu equal to n1 minus 1 comma nu 2 equal to n2 minus 1 degrees of freedom. That means we have to take f alpha, not t alpha. So f alpha at nu1 comma nu2 degrees of freedom. Nu1 comma nu2 degrees of freedom. So where nu1 equal to n1 minus 1 and nu2 equal to n2 minus 1. So next question. So next question is if x bar equal to 40, mu equal to 25, s equal to 8.4 and n equal to 24. So here also we have to use t equal to x bar minus mu by s by root n or root n minus 1. So next one is state the definition of the statistic for t-test for single mean. So t-test for single mean test statistic is here this one only. So t equal to x bar minus mu by s by root n, where x bar is nothing but sample mean. Sample mean is x bar and population mean is mu. Population mean is mu and sample standard deviation is s and sample size is n. So then the test statistic for single mean, this is nothing but test statistic for single mean. A test statistic for t distribution for single mean is, a t test for single mean is t equal to x bar minus mu by s by root n. So this is the formula for or the definition for t distribution for single mean. Next one, state the definition of degrees of freedom. So what is degrees of freedom? So the degrees of freedom is the number of state the definition of degrees of freedom, the number of values in the statistic is free or vary, or we can write this is our degrees of freedom is different for every value or every method in test of hypothesis for single mean and difference of means. So for test statistic, or for example in t alpha, t test for single mean, in t test for single mean the degrees of freedom is n minus 1. So in t test for difference of means, the difference of means is n1 plus n2 minus 1. So that is the degrees of freedom is different for every distribution or every test. So for f test, that is f alpha at nu1 comma nu2 degrees of freedom. So here degrees of freedom nu1 equal to n1 minus 1 and nu2 equal to n2 minus 1 degrees of freedom. Okay. Next, state the formula for the degrees of freedom for f test. So f alpha, we have to take f alpha at nu1 comma nu2 degrees of freedom. So where that is nothing but where nu1 equal to n1 minus 1 comma nu2 equal to n2 minus 1 degrees of freedom. Okay. So coming to the next question, find f 0.05 with 7 comma 8 degrees of freedom. So here also same, we have to take the degrees of freedom. So in f distribution, we have to take these values from the distribution table. So here we have nu1 values. These are all nu1 values and these are all nu2 values. Okay. So we have to take nu1 values. So let us consider this is nu1 and this is nu2. So here nu1 value 1, 2, 3, 4 like that we have. So we have to take at 7 and nu2 values are 1, 2, 3, 4, 5 like that up to 8. So we have to take, so these are all nu2 values. So we have to take nu1 is 7 and nu2 is 8. So we have to take this value from the F distribution table. So we have to take these values from F distribution table. F distribution table. So like that, next question is also same. Find T of 0.05 when 16 degrees of freedom. So in T distribution, so we have to take from the T distribution table. So table is like this. So here all we have all alpha values here we have new values. So these are all new values. So new 1, 2, 3 and so on up to 16 and so on also there. So we have to take 16 from new and alpha values 0. Here we have, for example, here this is 0.01, 0.05 is there. So we have to take this value here. Okay, so alpha value is here 0.05 and the new value is 16. We have to take this value from the distribution table. So next question is, a random sample of size 16 from a normal population. The mean of sample is 53 and sum of squares of deviations from the mean is 150. Can this sample is regarded as taken from the population having mean 56 at 0.05 level of significance? So here they have given that sample size, that is n value they have given in the normal population. The mean of the sample is denoted with x bar, and sum of the squares of deviations, that is nothing but the summation xi minus x bar whole square is equal to 150. And the sample is regarded as taken from the population having mean. Population mean is denoted with the mu. Mu equal to, here they have given that 56. What is alpha value? Alpha value is 0.05. Alpha value is 0.05. So here we need to find, we need to follow the procedure. First one is null hypothesis. Null hypothesis. So here we have to take directly mu value. Mu equal to, what is that value? 56. And second one is alternative hypothesis. Alternative hypothesis. The alternative hypothesis is here mu not equal to, or we can, yes, mu not equal to 56. And third one is level of significance. Level of significance. Level of significance, here we have to take alpha value. What is that value? So here we have to take T alpha at nu equal to single mean, no, nu equal to n minus 1 degrees of freedom. Okay, so T 0.05 at nu equal to, what is n value? 16 minus 1 degrees of freedom. So this is our next step. And the fourth step is, so here we have to use the formula. The formula is here T equal to x bar minus mu by s by root n. So what is x bar value? Here x bar value is 53. What is mu value? Mu value is 56. What about s? So s square, for s square we have n minus 1 into summation xi minus x bar whole square. So from that we can write this is 16 minus 1, that is we will get 15. So summation x this is 150. So that is 15 is there, that is total answer is 10. So s square equal to 10. So s equal to some 3 point something. So we have to use some 3 point something divided by 3 point something, 3.34 something divided by under root of n value. N value is 16. By using that one, we can find the t distribution, t test statistic t. And the final conclusion is here. The final conclusion is t, if modulus of t, if we find t value, no, if it is negative value also we can convert it to positive. So that is done. From that we will get modulus of t. Modulus of t is less than t alpha. We accept h naught. Otherwise, if modulus of t greater than t alpha, we reject our null hypothesis. That means we reject our statement. Okay. So, and the next question is find 0.95 with 19, 24 degrees of freedom. So, this value also we can take from the F distribution table. So, coming to the part A, 11th question. State the definition of statistic for the t distribution of t test for difference of means. The t test for difference of means test statistic is x1 bar minus x2 bar divided by s into under root of 1 by n1 plus 1 by n2. So this is the test statistic for t test for difference of means. And coming to the next question, find t 0.09 when 7 degrees of freedom. So this value also we can take from the distribution table, t distribution table. So next, coming to the next question, state the formula of the degrees of freedom for t test for t-test for difference of means. The degrees of freedom. So that means t-test for difference of means. Degrees of freedom is here. We have to take t alpha, or we can take t alpha by 2 at nu equal to n1 plus n2 minus 1, minus 2 degrees of freedom. Okay, so next question. Find t 0.95 when 9 degrees of freedom. We have to take this formula, this value from the t distribution table. So next, state the definition of test statistic for f test. So f test is s1 square by s2 square, where s1 square greater than s2 square, or f equal to s2 square divided by s1 square, where s2 square greater than s1 square. Next, 16th question. Find f 0.99 with 28 comma, that is, this is nu1 value, this is nu2 value, at degrees of nu1, nu2 values of degrees of freedom. So we need to find this value from the f distribution table. Just we go through the f distribution table. In that we have these are all nu1 values and these are all nu2 values. We have to take these values from the table. Next, state the formula for the sample variance and the sample standard deviation. So sample variance. So sample variance is denoted with s square. So that is equal to summation xi minus mu whole square by n, all divided by n. Or we can take n minus 1. Summation xi minus x bar whole square divided by n, or we can take summation xi minus mu whole square by n, or you can write x bar whole square by n. And standard deviation, we know that standard deviation is always nothing but under root of variance. And coming to the next question, state the formula of the degrees of freedom for chi-square test contingency table of order 4 by 3. So here, how many rows are there? So this is row. How many rows are there? 4 rows are there. And how many columns are there? 3 columns are there. So in chi-square distribution, chi-square alpha at nu equal to row minus 1 into column minus 1 degrees of freedom. So that's why here we have to take nu equal to row 4 minus 1 into 3 minus 1 degrees of freedom. So that is 4 minus 1 is 3 and 3 minus 1 is 2, that is 6 degrees of freedom here. Chi-square alpha we have to take at nu equal to 6 degrees of freedom. State the formula for test statistic for chi-square test. So chi-square test formula is chi-square equal to summation y minus ei whole square by ei. So this is the formula for chi-square distribution. So next last question is find chi-square 0.05 at 9 degrees of freedom. We have to take this value from the chi-square distribution table. So here all alpha values are there and here we have nu values are there. Okay, so at 9 we have to take alpha value is 0.05. We have to take this value from the table. Next, part B. Long answer questions. So first question is producer of gutka claims that the nicotine content in his gutka on the average of 0.83 mg. Can this claim be accepted if a random sample of 8 gutkas of this type have the nicotine contents of 2.0, 1.7, 2.1, 1.9, 2.2, 2.1, 2.0, 1.6 mg. So here they have given that mu value average. So this is nothing but here they have given that mu value, that is 0.83, and the random sample of 8, the sample size is here given that 8, and here they have given that xi values. So those are all 2.0, 1.7, 2.1. These are all xi values. Okay, so we need to find x bar. So how to find the x bar values? We know that x bar is nothing but summation xi by n. So that means summation xi, that means 2.0 plus 1.7 plus 2.1 plus 1.9 plus 2.2 plus 2.1 plus 2.0 plus 1.6 divided by n. So from that we can find x bar. So what is the actual formula? So here we have to use t-test for single mean. T-test for single mean. So what is the formula? T equal to x bar minus mu by s by root n. So but what is our procedure? I will show you the procedure is here. So first question, the procedure is same for all questions in module 5. Okay, so the procedure is, first one is we need to write the null hypothesis. Null hypothesis. So that is nothing but H naught. Okay, so here we need to write the alternative hypothesis. Alternative hypothesis. So that is H1. So next one is level of significance. Level of significance. And fourth one is test statistic. Test statistic. And the last one is conclusion. So for example, for this problem, here they have given that mu value. What is mu value? Mu value is some 0.83, right? So mu equal to, directly here I am taking that is 0.83, mu not equal to 0.83. So what is the meaning of null hypothesis? That is nothing but there is no difference between the means. Okay, so that is the population mean from the and the sample mean. So their alternative hypothesis is nothing but there is a difference between the means. Okay, so given statement is null hypothesis and opposite to the null hypothesis is the alternative hypothesis. So here the level of significance, if they have given, we have to take alpha value, but here they have not given, no, we have to assume that alpha value. Here I am assuming that alpha equal to 0.05. Okay, so in level of significance we have to take T alpha at mu equal to n minus 1 degrees of freedom for this question. Otherwise we have to take T alpha by 2 at mu equal to n minus 1 degrees of freedom. And the test statistic is, that is nothing but formula. Here we have to use that formula according to our first question, that is x bar minus mu by s by root n, or you can take s by root n minus 1. And also we need to calculate modulus of t. So what about the conclusion? The conclusion is here, if modulus of t less than T alpha by 2, we accept our null hypothesis. That means our statement. If modulus of t greater than T alpha by 2, we reject our statement. That is nothing but we reject our null hypothesis. So that is our first question. The first question formula is t equal to x bar minus mu by s by root n. And the procedure is same for the entire unit. Okay. So coming to the next question. A sample of 26 bulbs gives a mean life of 990 hours with standard deviation of 20 hours. The manufacturer claims that the mean life of bulbs 1000 hours. Examine whether the sample is up to the standard or not. So here observe carefully the sample size n equal to, they have given the n equal to 26, and mean life, the mean life of this one is that is x bar equal to 990 and standard deviation is s equal to 20. The manufacturer claims that the mean life of bulbs, so that is mu equal to 1000. So examining whether the sample is up to the standard or not. So same procedure for second problem also. Here also same, the formula is, here we are using t-test for single mean formula. So that is x bar minus mu by s by root n. So based on the values we can write the formula, but the procedure is same. First of all, we need to set up the null hypothesis. Next step is alternative hypothesis, and the next step is level of significance, and the next step is test statistics. In the test statistics, we have to use the formula, and the last one is conclusion. If modulus of t less than T alpha by 2, we have to accept, or we accept the null hypothesis. If modulus of t greater than t alpha by 2, we reject the null hypothesis. So next question. A random sample of 10 boys had the following IQs: 70, 120, 110, 101, 88, 83, 95, 98, 107, 100. Do the data support the assumption of population mean IQ of 100? Examine the truth value of claim at 5% level of significance. So observe carefully. Here they have given that n value. Okay, so this is also like a first problem. Okay, so here also they have given n value, and they have given mu value. Population mean is nothing but mu. So, and we need to calculate x bar. X bar is nothing but summation xi by n. So these are all xi values. These are all xi values. So we need to calculate x bar, that is nothing but summation xi by n. That means that is 70 plus 120 plus 110 plus and so on up to 100 divided by what is n value? N value is 10. Okay, like that we can calculate x bar. Okay, so what is the formula? Same formula, x bar minus mu by s by root n. Here also we have to use same formula. Here they have mentioned alpha value. What is alpha value here? Here alpha is 5%. That is nothing but 0.05 level of significance. Okay, so these three problems are the same formula we are using, same procedure we are doing. So next question. The mean of two random sample of sizes 9, 7 are 196.42 and 198.82. The sum of squares of deviations from their respective means are 26.94 and 18.73. And can the samples be considered to have been the same population? So here they have given the sample sizes, that is n1 and this is n2, and they have given the means. So this is x1 bar and this is x2 bar. Okay, so and here they have given that sum of the squares of deviations from the means. So that means summation xi minus x1 bar whole square equal to 26.94 and summation xi minus x2 bar whole square equal to 18.73. So we need to calculate s1 square. So that is 1 by n1 minus 1 summation xi minus x1 bar whole square. So we know that n1 value and the summation xi minus x1 bar whole square value. From that we can calculate s1 square and s2 square equal to, so 1 to n2 minus 1 summation xi minus x2 bar whole square. Okay, so this is s2 square. So otherwise here they have given that. So we have to use if s1 is greater than s2, we have to use s1 square by s2 square. We are using F distribution formula. Otherwise, we can use S2 square divided by S1 square, that is S2 square greater than S1 square. So, for the same question, we have to use T distribution also. So, for this T distribution, we have to find S square equal to 1 by N1 plus N2 minus 2 into summation Xi minus X1 bar whole square plus summation Xi minus X2 bar whole square. X2 bar whole square. So by using this one, we can calculate S square. From that we can calculate S. So the formula is T equal to X1 bar minus X2 bar divided by S into under root of 1 by N1 plus 1 by N2. So here they have given that X1 bar value and they have given that X2 bar value. So we have to use this formula also. T equal to X1 bar minus X2 bar divided by S. What is S? S is this one. So from that we can calculate S value. Okay. So that is variance S square. From that we can calculate standard deviation S. S into we have 1 by N1. So what is N1? N1 is 9 and N2 is 7. Okay. So the procedure is same. We have to follow this procedure only. But here in T distribution for difference of means, we have to use x1 equal to x1 bar equal to x2 bar. That is nothing but there is no difference between the means. Okay, so here we have to take x1 bar not equal to x2 bar. There is a difference between the means. Okay, so and the level of significance, they have given that alpha value, right? No, they have not given. So that's why we have to assume that alpha equal to this one. And what about t distribution for difference of means formula? So we have to take t alpha by 2 at mu equal to n1 plus n2 minus 2 degrees of freedom. N1 plus N2 minus 2 degrees of freedom we have to take in the level of significance. So what about the formula? The formula is this one. Instead of this one, we have to use second formula, that is t equal to x1 bar minus x2 bar divided by s into under root of 1 by n1 plus 1 by n2. So that is t test for difference of means formula. So next again conclusion. Conclusion is same. If modulus of t less than t alpha by 2, we accept the null hypothesis. If modulus of t greater than t alpha by 2, we reject the null hypothesis. So coming to the next question. In one sample of 8 observations, the sum of squares of deviations. So one sample of 8 observations means here they have given that n value, the sum of squares of deviations from the means, that is nothing but here they have given that summation xi minus x1 bar whole square, and this is n1. Okay, so and another sample we have given one more sample. No, that's why let us consider this is n2 value, and the sum of squares of deviations from the means here this is nothing but summation xi minus x2 bar whole square value. Okay, so they have given n1 equal to 8 and n2 equal to 10, and the summation xi minus x1 bar whole square equal to they have given that 84.4, and summation xi minus x2 bar whole square equal to 102.6. Okay, so at the level of significance alpha equal to they have given that 5%. So again same procedure. Okay, so you have to follow fourth one procedure. Here also same, we are using t distribution or t test for difference of means. The formula is this one. Next question. So next sixth one. 2 random samples gave the results. So sample size n1, this is n2. Sample means this is x1 bar and this is x2 bar, and summation xi minus x1 bar whole square, and this is summation xi minus x2 bar whole square. So here also same procedure, you have to follow the fifth problem procedure. So that is x1 bar minus the formula is x2 bar divided by s into under root of 1 by n1 plus 1 by n2, where s square equal to 1 by n1 plus n2 minus 2 into summation xi minus x1 bar whole square plus summation xi minus x2 bar whole square. Okay, so from that we can calculate S is nothing but under root of variance. So now next coming to the seventh problem, 2 independent samples of the items are given respectively had the following: sample 1, sample 2 they have given. Examine whether there is any significance difference between the means. Difference between the means means here also we have to use same formula, t equal to x1 bar minus x2 bar divided by s into under root of 1 by n1 plus 1 by n2, where s square equal to 1 by n1 plus n2 minus 2 into summation xi minus x1 bar whole square plus summation xi minus x2 bar whole square. So from that we can calculate s value. Okay, so after that you have to substitute all these values here. So what is n? 1, 2, 3, 4, 5, 6, 7, 8. So here n equal to nothing but n1 is 8 and n2 is 1, 2, 3, 4, 5, 6, 7. n2 is 7. So what is x1 bar? x1 bar is summation xi by n. So that means 11 plus 11 plus 13 plus 11 plus and so on up to 14 divided by n value is 8. Like that you can calculate x2 bar, that is summation yi, that is x bar whole square. That means summation of these values 9 plus 11 plus and so on up to 10 divided by n value is here 8. Okay, so what about this one? We need to calculate summation xi minus x1 bar whole square. So how to calculate this one? So these are all xi values, right? So xi values 11 minus, if you get some 10, no, if x1 bar equal to 10, then we have to take 11 minus 10 whole square plus 11 minus 10 whole square plus 13 minus 10 whole square. So like that we can calculate summation xi minus x1 bar whole square, and also we need to calculate summation xi minus x2 bar whole square. So again we have to use same procedure for seventh one. Okay, like sixth problem. So eighth problem, coming to the eighth problem, time taken by workers in performing a job by method 1 and method 2 is given below. So method 1, so here they have given that n equal to, so this is n value 1, 2, 3, 4, 5, 6. So n equal to 6 and n1 equal to 6 and 1, 2, 3, 4, 5, 6, 7. So n2 equal to 7. Same procedure. Summation xi, x bar equal to. So x bar equal to summation xi by n. So like that y bar or x1 bar. This is x2 bar equal to, this is also summation xi. Let us consider. Otherwise you can take that is yi. So that is summation yi by n. Okay. So and also you need to calculate xi minus x1 bar whole square and summation xi minus x2 bar whole square. So again you have to use same procedure like sixth problem. Okay. But here they have mentioned variances, right? So variances we have to use here next formula. So that is here s1 square equal to 1 by n1 minus 1. We need to calculate summation xi minus x1 bar whole square and summation xi minus x2 bar whole square. So after that we need to calculate s1 square. S1 square equal to 1 by n1 minus 1 into summation xi minus x1 bar whole square. So s2 square equal to 1 by n2 minus 1 into summation xi minus x2 bar whole square. So let us take the formula for f distribution or f test because they have mentioned variances. Based on variances mean we have to use f distribution or f test. So that means s1 square by s2 square, where s1 square greater than s2 square, or we can use f equal to s2 square by s1 square, that is s2 square greater than s1 square. The procedure is same. So here also same, we have to use so here also same, we have to set up the first step is null hypothesis. So for f distribution, the procedure is first null hypothesis. Null hypothesis, that is nothing but h naught. So that is s1 square equal to s2 square. Okay, that is totally based on variances. No, that's why we are writing alternative hypothesis. That is nothing but h1, that is equal to s1 square not equal to s2 square. So third one is level of significance. Level of significance. So here we have to take f alpha at mu1 comma mu2 degrees of freedom. Okay. So here mu1 equal to n1 minus 1 and mu2 equal to n2 minus 1 degrees of freedom. So third one is test statistic. So here we have to use f equal to s1 square by s2 square, where s1 square greater than s2 square, or f equal to s2 square by s1 square, where s2 square greater than s1 square. So this is fourth step, and the fifth step is here conclusion. What is our conclusion? If modulus of f less than f alpha, this is here here we have to take modulus of f. If modulus of f less than f alpha, we accept null hypothesis. If modulus of f greater than f alpha, we reject null hypothesis. So this is our procedure for f distribution. Okay, so coming to the next question, the number of automobile accidents per week in a certain area as follows: 10, 12, 8, 20, that is 2, 14, 10, 15, 6, 9, 4. The, are these frequencies in argument with the belief that accidents were same in the during of 10 weeks. Okay, so here we have to use chi-square distribution method. Okay, so for the chi-square distribution, So the chi-square distribution formula is, this is chi-square distribution procedure. Okay, so first one is null hypothesis. In the null hypothesis, we have to set up y equal to ei, and the alternative hypothesis. So that is y not equal to ei. So next one is alternative hypothesis is nothing but opposite to the null hypothesis. Next one is level of significance. Here we have to take chi-square alpha at nu equal to n minus 1 degrees of freedom. So this is important here. So next one is test statistic. So in test statistic, we have to use chi-square equal to summation y minus ei whole square by ei. Okay, so where y is nothing but observed frequency and ei is nothing but expected frequency. Okay, so the expected in chi-square distribution, the expected frequency is having 3 methods. Okay, so last one is here we need to calculate modulus of t chi-square, and last one is conclusion. So modulus of chi-square less than chi-square alpha, we accept h naught. So modulus of chi-square greater than chi-square alpha, we reject null hypothesis. Okay, so this is our procedure for chi-square distribution. Okay, so here they have given that frequencies. So the frequencies are here y values. The given frequencies are nothing but y values. Here in this method we have, so in 9th question, here they have given n value, and here they have given the frequencies. The given frequencies are observed frequencies, y values. Okay, so we need to find the expected frequencies. Expected frequency is nothing but average of observed frequencies. That means 12 plus 8 plus 20 plus 2 plus 14 plus 10 plus 15 plus 6 plus 9 plus 4 divided by 10. So that is nothing but expected frequency. Okay, so the formula is here y chi-square equal to summation y minus ei whole square by ei. So okay, so that is our 9th question procedure. The procedure is same for every chi-square problem. Okay, so and coming to the 10th question. So here a die is thrown 264 times with the following results. Prove that the die is unbiased. So in this case, we have to use chi-square distribution for second method, fitting of a binomial by using binomial distribution, Poisson distribution, or by using the average of observed frequencies. But in this case, I am using the average of observed frequencies. That means here we have to use same procedure. EA equal to average of observed frequencies and chi-square equal to summation y minus EA whole square by EI. So next, coming to the next question, 200 digits were chosen at random from the set of tables. The frequency of the digits. Here they have given the digit values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and the frequencies. Let us consider this is y. These are all y values, observed frequencies. The given frequencies are observed frequencies. Here also same, we have to use chi-square distribution formula, that is summation y minus ei whole square by ei. For the expected frequencies, I am taking average of observed frequencies. So coming to the next question, estimate the expected frequencies by using Poisson distribution to the following data and examine goodness of it at 0.05 level. So here they have mentioned Poisson distribution. No, that's why compulsory for the expected frequencies we have to use Poisson distribution formula. The expected frequencies for Poisson distribution for that EI values. For those EI values, we have to find n into p of x equal to x, that is equal to n into, in Poisson distribution, the formula is e power minus lambda into lambda power x by x factorial. So n into e power minus lambda power x by x factorial. For the expected frequencies, we have to use this formula. The main formula is same. Okay, chi-square equal to summation y minus ei whole square by ei. So that is the formula for 12th question. So next, coming to the 13th question, the given below is the number of male births in 1000 families having 5 children. The males are here 0, 1, 2, 3, 4, 5 and the number of families are. So here also same, we can use method 1, that is nothing but EI equal to average of observed frequencies, or we can use by using okay, in the question they have mentioned that we have to use the binomial distribution, so that's why we can't use this method. So we have to use here for the expected frequencies, the formula is there, n into p of x equal to x, because in our question they have mentioned by using binomial distribution we can fit the chi-square distribution. Okay, so n into p of x equal to x, that is equal to n into, so binomial distribution formula is ncx p power x q power n minus x. So by using this formula we can find the ei values, and they have given that oi values. Given frequencies are always observed frequencies. We need to find the expected frequencies by using this formula. So the main formula is here summation y minus ei whole square by ei. So this is a chi-square distribution formula, but here also same, we have to use the procedure of chi-square distribution. First we need to set up the null hypothesis, after that alternative hypothesis, and third one is level of significance, and fourth one is test statistics. Here we have to use the formula, and fifth one is conclusion. So if chi-square alpha modulus of modulus of chi-square less than chi-square alpha, we accept null hypothesis. That means given statement, if modulus of chi-square greater than chi-square alpha, we reject our statement, our null hypothesis. Okay, so now coming to the 14th question, 5 dice are thrown 96 times. The number of times showing 4, 5, 6 obtain the given below, and here they have given x values and the frequencies fi values, and here also same, we need to fit the binomial distribution. Okay, so again we have to follow the same procedure like 13th question. Next, part below, in part B, 15th question. A survey of 240 families with 4 children each revealed the following distribution: male births. So that means here these are all xi values, and number of families, that is nothing but frequencies, oi values or f values. Okay, so examine whether the male and female births are equally popular by selecting the suitable probability distribution for the computing expected frequencies. That means probability, here we have to use the probability distribution. So we have 3 probability distributions are there. First one is binomial and Poisson, and last one is normal. But in for finding the expected frequencies, we need to use only 2 methods. First one is binomial distribution and second one is Poisson distribution. By using binomial distribution, we can find the problem like 14th question. Okay, so again here also same, you need to follow the 14th question procedure. Now coming to the 16th question, the average breaking strength of steel rods is specified to be 18.5 thousand pounds. Sample of 14 rods. 14 rods were tested. The mean and standard deviation obtained were 17.85 and 1.955 respectively. Is the result of experiment significant? So here they have given that average of. So that means here this is mu value and sample. Sample is nothing but n value. Here they have given that n value and the mean of the population. So let us consider this is mean. So here mean of the sample is x bar and the standard deviation is s. So here we have to use t-test for single mean. Already we have discussed, no? So that is x bar minus mu by s by root n. So we have to use t-test for single mean formula because they have given the values which will be fitted to this formula. So that's why we have to use t-test for single mean. Here remember one thing, t-test, the degrees of freedom is t alpha by 2 at n minus 1 degrees of freedom. This is most important. Okay, so coming to the 17th question, a group of 5 patients treated with medicine A, weight is 42, 39, 48, 60, 41 kgs. Second group is 7 patients from same hospital treated with medicine B, weight is 38, 42, 56, 64, 68, 69, 62 kgs. Do you agree with the claim that the medicine B increases the weight significantly? So that means here N1 is this one, and these are all xi values. From that we can find x1 bar, and this is N2. So these are all xi values. From that we can find x2 bar. So the formula is here, we have to use the t-test for difference of means. So x1 bar minus x2 bar divided by s into under root of 1 by n1 plus 1 by n2. So now coming to the 18th question. In a sample of 10 observations, the sum of squares of deviations of the sample values from the sample mean was 120. In the other sample of 12 observations, it was 314. Examine whether the difference is significant at 5% level. So here also same, they have given that x1 bar, and they have given that summation xi minus, this is nothing but summation xi minus x1 bar whole square. So this is n2 value, and they have given that summation xi minus x2 bar whole square. So we have to use same procedure. Okay, so but for finding s value, we know that s square equal to 1 n1 plus n2 minus 2 into summation xi minus x1 bar whole square plus summation xi minus x2 bar whole square. Otherwise we can use F distribution also. So coming to the 19th question, the following table gives the classification of 100 workers according to the gender and nature of the work. Examine whether the nature of work is independent of the gender of the worker. So here they have given that some rows and columns. Okay, so that means here we have to use chi-square distribution, summation y minus ei whole square by ei. So we have to use chi-square distribution formula. So the given frequencies are observed frequencies, y values. So if you take column wise, you have to take column wise in the expected frequencies also. If we take row wise, we have to take row wise in expected frequencies. So, but how to find the expected frequencies here? So the expected frequency is nothing but ei values, that is equal to, here we have to take row total into column total divided by grand total. Okay, so we have to use this formula to find the expected frequencies. The given frequencies are observed frequencies. These are all observed frequencies. Okay, so next question, coming to the next question. The following random sample of measurements of the heat producing capacity of specimens of coal from two mines. So first mine 1 is this one, and mine 2 is this one. Use the 0.05 level of significance to examine whether it is reasonable to assume that the variance of two populations are equal. So that means here they have given that what is n value? 1, 2, 3, 4, 5. So this is n1 equal to 5 and n2 equal to 6. Okay, so these are all xi values, and these are also xi values. So if you want to find the xi values here, we have to use x bar equal to summation xi by n. So this is x1 bar for x1 bar. So for x2 bar, for this one, I am using for x2 bar summation xi by n. Okay, so now here we have to use s1 square equal to 1 by n1 minus 1 summation xi minus x1 bar whole square. So for that we need to find summation xi minus x1 bar whole square. After that we need to find s1 square. So like that s2 square equal to 1 by n2 minus 1 summation xi minus x2 bar whole square. Okay, so here we have to use F distribution. So which is greater value, we have to write in the numerator. That means if f equal to s1 square by s2 square, so s1 square is greater than s2 square. Okay, otherwise we have to use f equal to s2 square divided by s1 square, where s2 square greater than s1 square. So this is F distribution formula. So in for the 20th question, we have to use F distribution formula. So now coming to the part C, problem solving and critical thinking question. First question, a mechanist making engine parts with the axle diameters of 0.700 inch. So here they have given that this is mu value. Here mu value is 0.700 and n equal to 10, n equal to 10, and this is x1 bar equal to 0.742, and standard deviation s equal to 0.040. Okay, so we have to use t-test for single mean. That means x1 bar, sorry, x bar minus mu by s by root n formula. Already we have discussed now. So coming to the second question. So here they have given that xi values, and this is also some yi values. Otherwise we have to take xi values. So from this we can find 1, 2, 3, 4, 5, 6, 7, 8, 9. So n1 equal to 9 and n2 equal to also 9. Okay, so here also same, we have to use a t-test for difference of means, or we can use f-test. Okay, so if I use t-test, we have to find x1 bar and x2 bar. So this is summation xi by n and summation xi by n2, n1. This is okay. So now t-test formula is x1 bar minus x2 bar divided by s into under root of 1 by n1 plus 1 by n2. So coming to the next question, third question, the samples of 8 and 7 items respectively had the following values. Sample 1, sample 2 is the difference between the means. Here also same, we have to use t equal to x1 bar minus x2 bar divided by s into under root of 1 by n1 plus 1 by n2. We have to use t-test for difference of means. For the fourth question, the pumpkin were grown under 2 experimental conditions, 2 random samples. So here they have given n1 and n2 values, and the sample standard deviations are so s1, s2. And assuming that the weight of the distribution are normal, examining the truth value of the hypothesis that the variances, that means here we have to use f-test, that is s1 square is s2 square. So s1 square divided by s2 square, where s1 square greater than s2 square. Otherwise we have to use f equal to s2 square divided by s1 square, where s2 square greater than s1 square. So now coming to the fifth question, from the following data calculate whether there is any significant liking in the habit of taking of soft drinks among the categories of employees. So here they have given some rows and columns. So for the expected frequencies, EI values, we have to use row total into column total. So this here we need to calculate row total and column total also, and grand total. Okay, so row total into column total divided by grand total. So this is for finding the expected frequency. The main formula is here summation OI minus EI whole square by EI. So here these are all OI values. Given frequencies are always observed frequencies, and the expected frequencies, for expected frequencies we have to use row total into column total divided by grand total formula. So now coming to the next question. So here performance test. So in an investigation, here also same, we have to use observed frequencies. The given frequencies are observed frequencies, Y values. Okay, so if you take row wise, you have to take the expected frequencies also by using row wise. So that means here we have to take row total into column total divided by grand total. The formula is same, chi-square equal to summation OI minus EI whole square by EI. So this is the formula. So next question. So we have to use same formula, but the difference is here we have to fit the binomial or Poisson distribution, or here they have mentioned that both distributions. Okay, so binomial and Poisson distribution. So we need to find the expected frequencies, EI values, by using n into P of x equal to x. So here you have to use Poisson distribution formula, or using binomial distribution formula. So for Poisson distribution, this will be n into e power minus lambda power x by x factorial So for this formula for binomial distribution, this is n into ncx p power x q power n minus x. So, but the formula is same, chi-square distribution formula. So for the 8th question, so here they have given means and standard deviation and sample sizes. So this is n1 and n2. Means are nothing but x1 bar, x2 bar, and standard deviation s1, s2. So here the question is calculated, shown, make, examine the significance difference between the means. Means means here we have to use x1 bar minus x2 bar divided by s into under root of 1 by n1 plus 1 by n2. So here you need to remember one main point. So if they have given based on means, we have to use t-test. So t-test is based on means, f-test is based on variances, and chi-square test is based on frequencies. Okay, so this is based on means, this is based on variances, and this is based on frequencies. And coming to the last question, here also same, they have given some xi values and some yi values are this is also, you can take xi values, from this we can find x1 bar, and from this we can find x2 bar. Okay, so and we have to use, this is based on variances. Now we have to use f test, s1 square by s2 square, where s1 square greater than s2 square. Otherwise you can use f equal to s2 square by s1 square, where s2 square greater than s1 square. And coming to the last question, so here we have to find for means. That means here also same, we need to follow x1 bar minus x2 bar, x1 bar minus x2 bar divided by s into under root of 1 by n1 plus 1 by n2. So this is the formula. We have to use this formula. So this is module 1 question, module 5 question bank solutions. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.